Hello, my name is Ryan Berlin, Digital Content Manager for FacilitiesNet.com. Thank you for attending today's webcast, Smart Integrated Building Designs Best Kept Secret. Our presenter today is Brad Bonfiglio, Consultant Solutions Architect for Schneider Electric. Brad manages a national team that provides solution architecture support for the Schneider EcoStruxure building solution. Brad also recently presented cybersecurity as it relates to controls on behalf of the Winter ASHRAE Expo at BACnet International. Brad brings more than 20 years of experience in the building management solutions, security, and energy management industry. He holds a Bachelor of Science in Industrial Engineering from the University of Florida and an MBA from the University of Dallas. Today's learning objectives include reviewing the effects of connectivity and digitization on facilities, defining intelligent buildings and how they interact with one another. We're going to summarize the key components of Master Division 25 specification and analyze use cases affecting energy codes, wellness, and workplace efficiency. Before we get started, I'd like to cover a few details about today's event. A live question and answer session will follow today's presentation. To submit questions, please use the Q&A panel on the right-hand side of your screen and send your questions to all panelists. Our presenter will answer as many questions as time permits. Today's event will also include an interactive multiple-choice polling question. We ask that you do participate in this poll as your input is very much appreciated. At the conclusion of today's webcast, you will receive a PDF copy of today's presentation slides, and you will also receive a link to a brief online assessment. Upon successful completion of this assessment, you will receive your CEU certificate. Today's webcast will also be archived at facilitiesnet.com/webcasts. And with that, I'll turn it over to Brad.
Thank you very much, Ryan. Thank you all for having us here. Really do appreciate it. Good afternoon, everybody, except for, I guess, on the West Coast. For the rest of the country, it's good afternoon, other good morning. So I wanted to kind of fill you in. I'm Brad Bonfiglio, by the way, and that was a very nice introduction. I have the privilege of leading a team across the country that actually helps consulting engineers, specifiers, design build contractors, owners, specify and design, if you will, intelligent buildings. Of course, intelligent means a lot of definitions to a lot of folks, and I'll kind of go through that a little bit through our presentation. So today, I want to go through our agenda and talk about, we're going to talk a little bit, just one slide on who is Schneider Electric. A lot of folks don't know who we are. They think we're either a trucking company or a lighting company, or even an elevator company. So I want to fill everybody in on who is Schneider in one slide. And then I want to talk about the trends of what we're seeing in the industry that's driving this connectivity. Kind of want to help define what we're thinking of as an intelligent building, though there's probably many ways to define that in the industry. Division 25 specifications, what it is, how we use it, and then some use cases that are actually in the Division 25 specification. So we're going to go through this as our agenda. It's about 40 to 45 minutes long, which will leave a good 15 minutes at the end for Q&A. So I encourage you to reach out with Q&A. The more we learn from the industry, the more feedback we get from folks is how we actually develop and continue to learn as we go through Division 25 and other intelligent building specifications. So the more questions, the better. So let's look at Schneider Electric. We're larger than most people think. We're a global leader in energy management. As you can see, we're well covered across the United States. In U.S. revenue last year, we were $29.1 billion. Last I looked, that's bigger than Starbucks, to kind of give you an idea of size. And we have over 150,000 folks in our company, spend a lot of money on research and development and developing new technologies. So when you look at us, most folks don't know who Schneider is, so we're becoming more of a brand name out there in the market, but most of us know us by a lot of our brand names rather than our company name. From the controls world, we've done a lot of acquisitions over the years. Some of the names you might recognize: Inventus, Barbara Coleman, Andover Controls, TAC. Our new offers are EcoStruxure Building, which actually links or connects to all our older technology platforms into one. We also have two card access security offers. We've got a standalone room control, which was Iconics. Veris, Telemechanique, PowerLogic are all things dealing with more on the power side. Squirty is probably the most well-known brand we have from our electrical. Wonderware is when you get an industrial, APC, Arriva, MGE, UPSs, data centers, and so forth, and then ASCO switching, power switching, and static switches, transfer switches. So those are the kind of things we kind of look at when we look at an integrated solution, is we go down into what are we already doing well. And so a lot of the use cases are combining multiple integrations into these platforms as well as others. So, but little education on us. So one of the things I want to point you to is at the end of this, we are going to show you a brief example of what is a Division 25 specification. If you go to this link here, and again, you're going to get provided a PDF of this, but if you plug this in, you are going to go to what we call a proficient portal. The proficient portal is made for external customers, consulting engineers to be able to register. If you register and you apply online for opt-in for email notifications, this is not a marketing arm. This is literally technical design specifications. So what you'll do is any webinars that we host, and we typically host one a month in addition to what we're doing today, we host one a month that's published on here so that you can actually watch them. Most of them are PDHs, some of them are CEUs, and then we can watch them online as well. There's also a link to what's called My Energy University, which is product agnostic about energy in the space, from DDC controls, what is it, to energy management and so forth. So anyway, a lot of good information on there. I encourage you to register. We have over 1,500 mechanical engineers right now that have registered, so good opportunity for that to get data. And the Division 25 specification will be located on there. If not, you can always drop me a note. It's supposed to be on there already. You can drop me a note and we can get it to you. So let's see what the trends are in the industry. When I look at what's driving this demand for connected, I look at, IoT, more IoT devices every day. Most folks think of their home is more connected than their office space. I know when I go to my office, I know I don't have control over my temperature in my area. I don't have control over my lighting. I go to my house and I use Alexa to turn on lights, adjust temperatures, and so forth. So, the home automation has come a lot further along than we have in buildings, but it's catching up. And part of that is because as the new generations come up, they want more connectivity. They're expecting that. When you look at data traffic, I heard the other day, Sprint, though I'm not advocating Sprint, but Sprint has their first 5G network in place. Now, one of the challenges is the phone technology hasn't caught up across, but 5G is supposed to revolutionize the industry with the speed of it. So all we're going to do is see data traffic expand exponentially as we see 5G even get more implemented across in the next couple of years. When you look at efficiency, you look at cost per square foot of energy. We've always had a play in the building world of trying to reduce energy and be as efficient as possible. But we're starting to get into things that are a little different now. We're looking at some of the certifications out there for buildings are looking at more of how can I bring a premium to the building from a value of cost and selling to renting. So I'll give you some examples in here of we're actually seeing connected buildings actually get a premium for their tenant space versus ones that are not. So what are they kind of expecting, the customers, developers, and so forth? So when you really look at this, if you look from the left, you look at open, efficient, engaging, and flexible. Those are kind of the things that we've been driving for years with a traditional control system. Temperature controls, you want it open, you want it efficient, engaging, you want it flexible so you can use it. Those are things we've been using for a long time. When you look at where we're kind of headed with new technology, is now with Extensible, we're kind of branching into the occupancy space to be able to look at the operator to see how can they control their space. Are they utilizing their space? There's an offer we have that's there's also a trend in the industry, not just us, but there's an offer out there that looks at occupancy analytics. There's companies looking for that for new buildings because they want to know how often a conference room is being utilized. If it's not utilized, reset temperatures in the space. If the desk areas aren't being used, do we really need all this real estate? Those are the kind of things that are driving the new connected offers going into the future. And then now there's almost never a conversation without cybersecurity and how are you secure and so forth. So we've had a number. This is a big topic where we have an entire cybersecurity team within Schneider that is able to provide details of that, and we're able to connect to a lot of the secure government networks, and so that's kind of the reason we have to have this level. But we've worked that into the product line. But this is kind of a conversation with security that is having a conversation almost every time, is how secure is it. And when you're looking at one of the last trends is when you're looking at informational technology and operational, they're starting to converge. You're starting to see that productivity, looking at more and more productivity improvement with a lot of the different standards that are out there. Energy performance, the number of net zero buildings is forecasted to explode. You're looking at intelligent buildings. We talked about premiums, and then cybersecurity, kind of really the sole thing that's combining together. When you really look at IT world doesn't want anybody to connect to their network because they want it completely locked down. When you look at operating, you want to be able to view information from home. You want to be able to change set points. So this is where that's converging, is there's more ways to connect from outside sources now into the building, whether it's VPN or other access means to be able to do that. So they're having to work much more together than they had in the past. So how do we define an intelligent building? So this is a good example of just one type of intelligence. One of the challenges we have is we've had folks that say, I want an intelligent building, design me one. The question always comes back is, how do you define that? Well, I don't know. What can you do? So this is kind of, okay, what can we do? Well, this is a day in the life of maybe an intelligent building as we might see it. So when you think about it, member of the staff comes up, they go to the parking garage, they go to the card reader, they get access to the garage, obviously if they have access rights. When you look at it, the security system not only picks them up, but the video says, yeah, I see their license plate, it's who we have. Maybe they have an assigned spot, maybe they have a spot that's multiple use or assigned during different parts of the day. Then you look at maybe it has EV chargers. Do we activate the EV chargers? Do they have access to charge their vehicle? Was that the right person, or is that someone just off the street bringing a vehicle in and tailgate it and go ahead and charge that vehicle? So there's things you can do now to link those together. They were to look at it, how do I get the space conditioned in some way, shape, or form for when they get there? If this is a person that arrives very early in the morning and they're the first person there, depending on the setback the night before, maybe it conditions just their space and operates the building as little as possible without turning it all on to make sure the comfort and lighting is on in that area for that person. When you look at office use, can they control their environment through their mobile phones? Can they control the lighting levels? And when I say lighting, it's not just simply on and off anymore. We talked of IoT. There's Philips Hue lighting, for example. You can tune in colors. Maybe you work more productive with certain colors in a space than just purely black or white or bright or non-bright. So those are the kind of things we can be thinking about when we think of a smart building, and those aren't too difficult to achieve. Then you look at things like Alexis. Alexa, and cloud connectivity. You say, well, wow, I don't see that in a bunch of spaces, but there are some one-off applications. We're doing some healthcare facilities right now where this is a big deal for them and certain patients because of the fact that the patients can't modify or change physically some of the information they have from like temperature and lighting, blind. So what they do is they can actually use this as an interface for that. We also see this as a sort of a leading technology that say you're a company, you want to kind of impress your clients, and you have a conference room, and you put this in there, and you go in there and you say we have the best technology, whatever that is, and say, hey Alexa, turn on my lights to 50% level, open my blinds. I mean, that's a pretty cool demonstration to show. Figuring if you could do that in a space, you ought to be pretty state of the art as far as a company. So just things like that, you're starting to see more of on one-offs. And then, of course, the ambient conditions in the building, the whole building. Do we need to ramp up based on CO2 levels? Is it correct? Is the right density? Again, you can sync things with occupancy analytics back to the CO2 to kind of do an optimal demand start, optimal control of demand ventilation. So there's a lot of things you can do nowadays. Then the facility managers, can they view all this? We talked about remote, on-site. Can I look at multiple systems in here, or do I have to have multiple screens to go to? The more the better as far as getting a single pane of glass, security and critical systems, text messages. We're starting to get into even, we've got a profile we're working on with our Division 25 on like an active shooter profile, that there's some conditions that we look at when there's an alarm from a security system. And then there's, how overall is the energy doing in the building? How's the performance? What's the KPIs? How was the energy today versus yesterday versus this month versus last month? Did it hit our year-to-year goal? Are we about to exceed our peak? Occupancy, where was the occupancy today versus yesterday, and so forth. So a lot of information, and these are all the things we can do today, without being pie in the sky and being things that we got to wait for the future. So this is just one example of an intelligent building. So when you look at another way to look at maybe a connected building, how does this kind of put together from a system level? We usually look at the HVAC because it's multiple communications usually is the core. And then you have things like interface to fire alarm, lighting and blind control. We talked about that. You'll see a use case here also in a little bit. When you look at power and energy metering, you always have to have some type of power in a building. A lot of times the meters are on the equipment itself. Sometimes a lot of them are not connected. But how do you take that to where you not only look at main power coming in, but sub power from central plants, from floor energy, lighting energy, plug energy, and so forth. And I'll show you another slide that kind of gets into that a little more. Card access. Most buildings have card access and CCTV. How well it's integrated is yet to be determined. There are integrations to BMS and card access. Access control is finally realizing that there is a backnet interface between them that can actually share data other than just dry contact closures. So there's more we can do with access control and CCTV than we had in the past. Smart grid, depending on where you're at in the country, this is a big deal. And microgrid, these are things you're starting to see more and more with looking at demand reduction. When you're looking at the cost per kW, kWh, does this make sense or not? We're starting to see more and more of that. And as you when you think about adding EV chargers to it, that directly affects this. So that is a really big deal now, that when you have a number of car chargers, that you're actually having to look at some type of technology to help manage that load. Since they're directly on the network. Occupancy, we talked about, that's really the new thing that's coming out. There's a bunch of companies out there that are all trying to race to this space, depending on the applications. And so that's really the forefront of what we're seeing. And really it's a matter of how do we make a building future-proof today for tomorrow. And those are the things we're having conversations about. And then last is analytics, web services. So what you find is what the real trend in the industry has changed is we're starting to see a lot more services in the cloud. Part of that is the physical throughput, the physical, if you will, memory, physical processing power of these subsystems that we show here are not able to handle what a cloud computing can do. So a lot of solutions are pumping information to the cloud, depending on what they are, to analyze and then share that data. So that's really changing a lot of the forefront of what we're seeing in intelligent buildings. So how would this might look in ASHRAE? So we looked at it as connected and intelligence. Let's look at it from like an ASHRAE perspective. ASHRAE 90.1 is on sustainability and energy. And there's a number of things that you can see on here from the mechanical side at the top that connected brings value to ASHRAE standard. Obviously on the bottom, electrical. And some of those standards even get into plug load, parking lot, reduction in power, and so forth. So some things start to get pretty connected in there and would be very difficult to achieve as a standalone basis. And then all that can be rolled up to, again, fault detection, cloud, preventative, predictive, proactive type maintenance, as well as analytics and predictive, especially not only occupancy, but even weather predictions. There's some weather analysis integrations we have. So let's talk about Division 25. So this is a little bit of a corny slide, but I think it hits the point of some of the perceptions and why we kind of need something to kind of bring all these systems together. So, you know, when you look at it, this is how the customer explained what they wanted. This is how the project leader understood it. This is how the analyst designed it. Here's how the programmer wrote it. How the consultant described it. How the project was documented. What operations installed. How the customer was billed. How it was supported. And what the customer really needed. So this kind of gives you an idea as we go through the construction chain, the specification chain, the contract installation phase. A lot of things can get confused on what the intent is of the project. And that's kind of why we're doing this or looking at more using Division 25 is to help drive what is the customer's expectation and what does the customer need and what do they get. So what is a Division 25 specification? It is a American Institute of Architects CSI master format, so it's not something we invented. There is a Division 25 that's not used very often. The idea is it's used, we're using it, and it has been used as a high-performance building to get usually what the owners want. It's typically procured through a general construction manager, for example, or design build contractor. And the idea is because it does integrate other divisions, it usually needs to be above and beyond like a Division 23 mechanical. Obviously, it does have cybersecurity and some IP architecture in there. The need for that is you obviously don't want to connect systems together and have a vulnerability that we've introduced by not having it cyber secure across connected systems, and obviously we need some type of IP architecture to do that. In our case, we really look at it as not replacing 23 or other divisions. 23 is controls. It's actually, the whole 23 is HVAC systems, air conditioning, ventilation, and so forth. But in there's a subset for temperature controls. We didn't want to replace the entire DDC or temperature controls for HVAC. We wanted to supplement that. 26 has not only lighting but power, again, not replacing all that, just complementing it. And then 28 is typically around security cameras and card access. There's another one in there that I don't mention is starting to become more and more. It's 27, which is a technology section. So we're starting to see a little bit of this 25 actually being at 27, but that's still new and becoming that standard. And then we actually include in our use cases for integration, this is how they would actually work together between systems. So why use it? The idea was to gain interoperability between siloed divisions, as you can see here. Kind of gives the owner more of what the performance of the building is going to be. There are some savings you could have. I'm not going to say it's 100% savings, but there are things that are duplication between divisions that can be combined. And again, what can be combined and what makes sense. And then there's definitely energy sustainability. There's all kinds of things that are related to that, whether it be efficiency and so forth. So there's a lot of reasons you'd want to have a Division 25. So what are some of the benefits to this? I think we kind of talked about, but really it's trying to get whatever the future is and trying to be as much connectivity or open to connectivity as possible. A lot of this goes with designing a building around an IP network. And Wi-Fi and low voltage Bluetooth and other technologies that allow piggybacking of other technologies over the years. I don't know what the technology is going to be or the new technology in 3 years from now, whether that be the new connected device that I bring a mobile phone to, or whether I connect a new app. I don't know what all those are. I don't know if the meeting rooms, for example, or the projectors are going to come with connectivity. Just like you would for anything else like Wi-Fi. So, all that's coming. A lot of them are Wi-Fi already, but, that's the kind of stuff that in the future, I don't know what all we're going to get. So the more open we have today, the more infrastructure, IP technology we have, the better. From a customer experience, obviously, quality, efficiency, we kind of talked about a lot of that. From a risk, one of the things we can offer with connected systems, there's a number of cloud offers out there that can help you do commission verification. Basically, you're helping qualify and verify the consultant's original design intent is what's being met when the building's handed over to the owner as far as the performance. The use cases are actually shown so we can actually do what is that performance. And then a lot of this we talked about on that chart earlier about documentation or lack of. What we're seeing is a lot of times what Schneider has done and others have hopefully done is they come up with a TVDA document that actually when you do integrations between different systems, you actually document what those are, so that when the building gets turned over to an owner, they don't inherit something that does not communicate between them. They don't know how to support it. They don't know how it functions because there was no documentation. This actually helps with that architecture and communication, so you can kind of help support it after the fact. And then some of the added value or some return on investment tools that are built into some of the software suites. ECMs, energy conservation measures, or some things we can do nowadays to help you. If you fix this, repair this, you actually can help save energy by this much. We kind of give you a shopping list of here's the cost you're wasting in energy. If you choose to fix it, this will be the improvement on it. So there's a lot of other technology that's happening now in this space due to cloud computing. So let's go ahead and take a look at a few of the use cases. So when you look at a use case and how to design that, this is sort of the ideal way. You go to an owner, developer, what have you, whoever the stakeholders are. You ask, what is the mission? What are their KPIs? What are their goals on sustainability? What are their goals on energy? What are their goals on wellness? The productivity for the employees. Those are all the things you probably, ideally identify up front, so that as you build your model of an intelligent building, we're building those KPIs into it. And then you look at, okay, the owner, this is his vision. How do the functional folks work? Are they, for example, when you look at the building manager, how do they need to use it? The property manager, how do they need to use it? The tenants, how are they going to be able to access this? What data is important to them? So that's the functions of how the functions and the folks are going to be using it. And then, okay, we agree on this is what we want to do. What are the people that can make this happen, the folks that can install it, maintain it, or get it set up for maintaining, I should say. Who are the people going to do this? And then let's put, not only we got the team together, how do we put all the components together to make this work, and how we're going to connect this, how we're going to add equipment to get these KPIs. You would think this is the normal process. Well, it's actually opposite of what the industry does. What it is today they throw a whole bunch of technology at things, having no idea what the end goal is or what the owner wants. And so they throw technology upon technology at you. At the end, and then you throw a whole bunch of people at it to, go install this stuff that you don't know if anyone's going to need this stuff or not. And then you don't know what the functions are going to need it for. A lot of times the functions will come back and say, well, why'd you do it this way? We really needed it this way. Some of those things could have been easily defined in the beginning, but now it's a finished product. And then the owner may say, well, this is all nice, but this doesn't even meet the mission of our company. So why did we do this? And so these are the kind of things that is traditional. More of what we see is throw a bunch of stuff at it, see what sticks. So we're, hopefully the Division 25 is trying to change that a little bit with at least giving a functionality at the top. What could you possibly do with it? So let's go through a use case. So let's look at a use case of room control, speaking more of like a conference room almost. And what a use case is how do we do room control when you look at blinds, lighting, you look at card access, and of course HVAC control. So all those things come into effect. And troubleshooting, is it hot in here? When you get hot and cold calls, conference rooms are famous for that. I'm hot, I'm cold. So those are the kind of things. And some of this is, on existing buildings, you have challenges with the infrastructure was not designed right or had been retrofitted or renovated over the years, and the end result was not what the intention was in the beginning. So some of that stuff is beyond some control. But others, you can actually, if you can build it into a renovation or a remodel of a floor, these are the kind of things you might want to think about putting in. And then how do you integrate that into whether floor card access, meeting room card access, and so forth? Unoccupied, if it's not occupied, do we turn off or reset the temperature in a space? And we're actually starting to look at more into, how do we interface that into active shooter, which I'll show you here in a little bit of a conversation. So when you look at traditional lighting and building management, for example, a lot of times it's separate systems. If nothing else, you look at the different time clocks or time synchronization. It'd be kind of silly for the lights to be on when the air conditioner's not on, or in a setback mode, or the building management to be on when the lighting's not even on. So if nothing else, it's good to communicate and share data between them. A lot of times when we see specifications, especially in the BMS, it'll say one little line, it'll say integrate to lighting controls. That leaves a lot of interpretation of what that means. But if nothing else, you might want to look at least time clock synchronization and or occupied, unoccupied. So those are kind of things that don't know that could be helped defined in the beginning. Obviously, duplication of a lot of sensors and stuff. Might be looking at occupancy for the controls for space. Also doing the same thing for lighting. Why not combine some of those? You've already physically have it installed. Another way to look at it, that system independence, this is system to system, to where we actually have some type of communication. This is just one example of many, to where the lighting does integrate to the building management. One of the things that benefits is a time sync between them. You might be able to combine some of the user interfaces, some troubleshooting capabilities. Is there documentation how that integration works so that the owner can manage it after the fact? Are they going to be wired wireless? Is it a retrofit? Is it new construction? A lot of ways that you can combine systems there together. And really, the BMS is pretty capable of doing remote monitoring and remote control. How do you do some of that with maybe the lighting control as well to be able to do some things remotely? And then you got a situation where you're actually combining it all into the one room controller. To where it might have technologies on there in the upper hand side, maybe BACnet, maybe some Dolly, which is a lighting integration protocol. You might have low voltage Bluetooth. You might have Zigbee. You might have Wi-Fi. Those are all the kind of things that we're looking at because, again, we don't know what the future is. When you look down here at a smart garbage can, I mean, I haven't seen that in a space yet, though I have seen some restaurants, some fast food restaurants that have this, that actually have a trash compactor in there that'll send a signal to the staff that it's full. So I know it's starting to come. What that technology is in the future, I don't know. But whether you have control over that room, I know when I go to a hotel, and I do travel all the time, and I go to the hotel and I change the thermostat or try to change the temperature and I can't. It's been locked out somehow, or if I change it, it doesn't do anything. Obviously, someone's locked it out, and I'm still hot. So, what's that feeling like? It's pretty, I'm not happy. Let's put it that way. So the more control I can get over things, the better. So I usually have to call down to the front desk and say, hey, it's not working, when technically there's probably nothing wrong with it. They send somebody up. What they basically do is override the thermostat, let me have full control. But that's that feeling you have. Why not have some of that control in an office space, whether it's lighting levels, whether it's occupancy, and then you get things in there like card readers and displays. Do I need to have a scene in there to have my projector versus my lights? We're starting to see some where we actually have some interfaces to schedules like Microsoft Microsoft Outlook 365 with to be able to tie in schedules with Outlook into the BMS systems nowadays, to where you can actually schedule conference calls, for example. Conference rooms, I should say, and then be able to maybe lock and unlock a conference room or allow access during that time that someone has it reserved. So those are all the kind of things we can be doing, and then, of course, blind lighting control and so forth. Then navigate to the next screen here. Give me a second. There we go. So another use case we have, and these are simplistics, just summaries of these use cases. We're starting to see now, just like technology in the building space, starting to become more intelligent. The intelligence on the power side is also very intelligent, down to even the breaker level nowadays. Not only breaker status, but breaker monitoring of KWH on there. So when you start to get to that level, we're looking at more of the MCCs that come intelligent nowadays than we've ever had before. So one of the challenges is, how do you bring that data together? How do you utilize it? And things that we're seeing is LEED and WELL and others that are requiring this type of information already. So why not seize the most effective and efficient way of bringing that data in? So an example would be when you typically had duplicate information. It's very common where the Division 23 and Division 26 don't always communicate in coordination. And I've seen many times where the power meters come right on the gear, maybe not down to the breaker level, but at least the station level or the MCC level. And then you also, I've seen in a lot of cases, have duplicate meters downstream that really bring you a lot of the same. If you can combine more of that into the breaker side of it and get it from the factory already installed, that saves a lot of information. So by combining, and I'll show you here in the next slide. So one of the things, if nothing else, is it's pre-engineered and tested. So this is showing really a intelligent breaker system, intelligent management system from more of the factory installed, and then connecting that nowadays with communication bus directly to the BMS. A lot of times that happens, but a lot of times it's just on the mains coming in and not the subsystems underneath for sub-metering, for example. A lot of that can be done at the gear now instead of having to go and put in duplicate meters. So some of the things is just, if nothing else, when you look at the expertise on a power meter, the building management systems, for example, that's not the expertise unless an electrician's installing it. And when I say that, I experience a lot of sub-meters out there in the world that I've walked buildings on, and there's literally, it's not set up correctly. it was never set up because they probably don't know what the max power, the min power, what they were supposed to set up, the parameters from the electrical. Where if it's already installed from the electrical side in the beginning of the job, a lot of that's going to be set up correctly because that is the specialty for that group. So if nothing else, you're going to make sure that it is working and less disruptive conduit wire and so forth with adding external meters. Doesn't mean you're going to eliminate all of them, but the more you can eliminate from one spec side of the specification to the other, the better, instead of duplicating. And then when you do that, you actually integrate the two. There are some other benefits that you didn't get from just KW, KWH. You can start looking at energy performance, utility bill verification, and even power quality. There's a lot more information you get from meters other than just simply a Modbus register. There's a lot more information in the meter that's available if you have the right software tools to extract it. So why not connect into that extra level to give you extra information that was already available anyway at the meter level. Plug load control, as we're finishing up here, was the last one. We're starting to see some use cases with plug load control, and you go, well, why would I need that? Well, ASHRAE is one of them that's starting to require that. For energy savings, half of it actually has to be shut off, half the building's plug load. So that goes with coordinating big time on with the engineer on how you set up your circuits. Real quick on, before and after, you typically before you had to power some type of circuit breaker, and then you had to add a relay panel, multiple devices in there, spend the extra labor to do that. Nowadays, they have motorized breakers. So before and after almost look the same. Really, you can pick and choose which breakers are motorized. In the panel itself, it doesn't have to all be to where you can actually do some lighting control. And there's actually some of the panels now can be actually bought and purchased with CTs already built in on every circuit, so you can start getting into plug load analysis, not only control but monitoring of KW, KWH. And you can start tying in things like wireless sensors at that point, getting a little more intelligent than you had before. Obviously, there's some cost savings with that. So I just want to show you, this is an actual graphic from one of our buildings that we installed. I didn't give the customer's name in here did not want to share that. But I want to show you the actual graphic of, how we might be able to bring this information with the different use cases I just explained to real-time energy, solar, energy production, indoor air quality forecasting, even down to usage per cooling, heating, lighting, and plugs. So I can get a view of that. We're starting to see many more buildings wanting to know that in the beginning of their buildings to see how that changes over time. And a really nice one here is down to the bottom right, where you're actually seeing which part of the building's in mechanical cooling versus ventilation, which is really neat. Obviously, the sun's somewhere over here on the right side, where the left side's more in the shade, and they're actually able to show not having to run free cooling on the whole building or mechanical cooling on the whole building and how it's shared. Next one is really down to the floor level. You might look over here to the left where you've got plug load, energy load. You've got it broken up into lighting, plugs, mechanical. So you kind of get an idea of where the energy is and where it's spent. Lighting levels, which ones are on in kind of a graphical user interface. This was a building I wanted to give you some feedback on. This was the first well-certified building we were part of in New York. What's interesting is this, and I just want to highlight, their goal, the owner's goal, was to have the highest leasing rates in New York City by having an intelligent building, how they defined it. And you can see all the different solutions that they actually incorporated. But they actually had the highest leasing rates, and it's over 90% occupied today, $125 a square foot. And that's a pretty good penny for what that space is, and $300 for the penthouse. So they actually charged more for an intelligent building, and people are willing to get in there because of this and occupy this building because of their well certification. And then the last one I'm going to have is a statistic is CABA did a really nice report that you can look up on better buildings and the results. And they actually looked at some not only just energy savings, but they looked at productivity improvements with having intelligent building versus a non-intelligent building. And this was the first time I've ever seen a report that actually sort of quantified what those are. Now, it doesn't put into dollars, but you can see it actually relates to days and so forth. But, you know, as in a company, you can kind of equate that to dollars. If you put $1 per productivity level or turnover, I'm assuming most companies have some type of measurement on what that costs them. So this is the first time I've really seen it, and they did over a number of buildings, over 1,000 buildings they did a survey of. And then the last thing I'm going to finish up with is our Division 25. It is an AIA specification. I'm not going to open it in all the details. I do want to say that it's in a Word format. It has sections in there, as you can see over here to the right in red. The red are, you know, you can keep in or remove. So there's sections in there like that are kind of notes. The green is more informational that you can see, that you can take out. And just really of how the flow is, and kind of gives us some disclaimers and stuff. But basically, everything in red you kind of want to modify. It's product agnostic. It's not based on Schneider offer by name. There is one listing of us by name, but that's it. The rest of it's all product independent, so you can do what you want with it. It does include a flow chart over here to the left of how data is communicated. It does have in there not only this flow chart of who does what, but also a matrix of responsibility in one of the appendix that actually can give you a guideline of who might do what as far as the divisions 23, 25, and 26. So that's all I'm going to cover today. It really is an overview why, what, where, and how, and what the deliverable is. I do appreciate your time, but I'm going to open it up at this point for questions.
Before we get into the Q&A portion of our webcast here today, if everyone wouldn't mind, all the participants wouldn't mind taking some time to participate in our polling questions. We would really appreciate it. We're looking for some feedback, and all of your help would be very much appreciated. And while you guys are doing that, we're going to jump right into the Q&A portion here. So, Brad, the first question that we have is, how often do you see Division 25 being used?
Yes, that's a good question. It's starting to be used more and more. I would say it's not mainstream. There's probably a dozen consulting engineers and developers we're working with right now that are looking at using Division 25 for high-performance building. So it's not for everybody. A lot of, I'm going to say, non-intelligent facilities, or the goal is a non-intelligent facility with a lot of standalone systems, maybe nothing intended for lead or wellness, won't typically use this format. They'll go with their traditional 23, 26, 28, and so forth, in independent systems, whatever those technologies may be. So, but we are starting to see a trend where they actually, at the end of it, want information to share, and Division 25 is a good way for them to do that.
Great. And I wanted to, our polling questions are completed, so if anyone has a question, you can minimize the polling tab on the right-hand panel of your screen, and then you can expand the Q&A and just type your questions right in there, and we'll get answer them as we can. The next question that we have, Brad, is how much does a fully integrated office build-out typically cost in dollars per square feet, and what are the key components you can use to justify the additional cost?
Okay, I heard the question, but it really didn't define. I'm assuming they're talking about controls and integrated controls, and I say integrated, maybe a Division 25 is my assumption. We're not obviously able to give feedback on the construction costs of a renovation. When we look at, and assuming that was the question, when we look at the cost per square foot, especially in a renovation, it's a little trickier because of the fact you might have some existing infrastructure that you got to deal with and connectivity and so forth. So again, there's some existing stuff that you've got to take into consideration. But looking at it on a pure new construction standpoint, assuming you're starting from scratch on a new renovation area, and depending on obviously the size of the square foot, from what we've seen, and this depends on around the country, somewhere between $1 to $3 a square foot is what the controls is. When you add in Division 25 and start integrating systems, we've not done enough of these to look, but maybe it's somewhere between $2 and $4 a square foot. When you look at the total cost of a building and you look at the budget, and when we're basically 1% to 3% of the total construction budget, it's pretty small compared to what you think of as probably the biggest technology piece that you can put in the building. So we get all the time where I'm going to VE the controls or things with energy and so forth out of the building, and you're picking on something that's less than 5% of the building cost, but yet has the biggest technology impact. To me, that doesn't always make a whole lot of sense. I think I'd rather almost double my budget for the integration and controls and data that I'm going to get versus the opposite. But unfortunately, that's the division we're in today. Good question.
Okay, and the next question that we have is earlier you were talking about centralized control. So the question that we have is, how does centralized control protect against value engineering?
Okay, so that is a good question. I get that all the time. It doesn't eliminate it. There's always going to be value engineering, no matter what level you have in a construction cost project. I have not been in 20 plus years ever been on a project that actually was for the whole construction. I've never had one that was under budget. It always seems to be way over budget. And then at that point, they're in a cutting mode. When I look at the controls and the technology back to the big picture, it's rather small. The problem you get into, though, is it's that unknown. Nobody really knows what it is. It's this magic box that seems to do something. So it's always easy to go cut what you don't know. But again, why would you cut the technology off at the knees when you really need it? So to get back to your question, by putting the specification or going with a Division 25 and what the value is of doing it, it's not just saying, so in 25, we're not saying put in these meters. We're not saying put in this. We're not saying put in that. It's saying this is the value I'm going to get out of it. So if you do choose to cut a use case and all the features associated with it, then that is a choice. It could happen. But it's not as easy as just picking apart parts and pieces, because if you eliminate 1 meter, doesn't mean you're going to eliminate the entire use case. So it's a little more difficult to do, I would say, versus maybe having the controls in the Division 23. If that case, you're a sub to a sub, and if that case, you're a little more sheltered, and the VE gets if you will, more identified than other times. So 25 helps it become a little more sticky, if you will, because the owners actually get to see what they want and get, but it doesn't eliminate it completely. Good question.
And Brad, as you mentioned Division 23, do you see Division 23 combining it all with Division 25?
Yeah, that's a good analogy of what could. I mean, we've seen that happen, and we've seen it that way, and we've seen it other ways. So we've seen where Division 25 is included, 23 is all the way. All the specs from 23 are in 25. When you do that, you typically get a 100-plus page document for that, which for some contractors, some owners, that's acceptable. We looked at it as more of the 25 being an integration platform between systems. So we chose not to include everything from 23 into 25, and then same thing with 26 and 28. Not all of that technology is in there. A lot of that can be done in the independent channels or independent specs, but we actually want to, in our 25, combine them all together. And our Division 25 spec, because of that, is less than 30 pages with the use cases and architecture. So it's more of a functional and performance than it is all the technical details of what, like, for example, a power meter and all the specs around that. Good question.
And the next question kind of, I guess, as a follow-up, who's typically responsible for carrying Division 25? As mentioned, 23 is typically a sub to mechanical. So is Division 25 standalone vendors?
Yes, typically it is. Typically it's a person. The better way to look at it is an integrator that is responsible, that'll be reporting up to the general contractor or construction manager or even an owner. They'll be responsible for providing that integration and that technology and that data to be rolled up into 25, and they're responsible for coordinating with the other trades to make sure what's getting installed will actually function correctly. And that goes really back to the VE. So if you're VEing lighting controls down to non-intelligent lighting controls, it's going to be a little hard to incorporate the use case for lighting integration when there really isn't any intelligent lighting there in itself. So, it all goes kind of hand in hand. Most of the time we see that where there'll be kickoff meetings and coordination meetings in the beginning of the project so all the trades can get together and have those coordination communications. But yeah, usually it's a person that's done independently, and that can be combined with the same manufacturer as, say, the temperature controls and or security, and maybe all of those. So, but again, that leaves it up to the contractor, the general or general or construction manager to kind of make those decisions. There's a lot of options there.
And because there are so many options, like you just mentioned, what type of educational opportunities are available so people can find out more and learn more about this expertise? I'm assuming you're referring to expertise of, I'm kind of guessing here of what the question was, expertise of knowing how to integrate different systems, how you can learn more about it. There's a number of groups out there. There's actually an intelligent building community. They just had actually a convention, and it was part of Realcomm. They have nothing but integrated systems is what they're kind of coaching on and teaching. And they had guest speakers just like you would in any conference. That was last week in Nashville. So if you look at some of those intelligent buildings and some of those technologies, those are kind of really where folks are headed to gain more knowledge of how to get more information out of systems. And the last question that we have here is, how does the connection to CMMS and using Project Haystack for harmonization fit in?
Okay. Well, there's Haystack is synonymous with a number of different technologies out there, but so I'm not going to I'm going to table that side of it because that's sort of a whole separate subject. That's outside of Division 25. I will say that as Division 25, we do have an integration to the CMMS system, and basically for folks that don't follow that, that's work order systems. There's a number of them that we have interfaces to, one of them being like IBM's Maximo, and so that is where we're sharing data between the BMS and the work order system. Being two separate systems, obviously, but we're sharing data that the work order system can do or can act upon based on information that the BMS gives it, like runtime and so forth. So those are the kind of things we actually can do today and have a white paper and a document on how that integration works. So, yeah, that's stuff we're actually doing today.
Great. Thanks, Brad. And that's really all the time that we have for today. If we didn't get to the question, your question that you wrote down, we'll try our best to email you a response and get it to you. And I'd like to thank everyone for joining us today. Thanks to Brad and Schneider Electric. And as a reminder, you will receive a PDF copy for today's presentation slides and a link to a brief online assessment. Upon successful completion of this assessment, you will receive your CEU certification. And for a copy of today's webcast and all archived webcasts, please visit facilitiesnet.com/webcasts. Thanks everybody again, and thank you, Brad.